Okay, students, take a moment, sit tall. Ready, and inhale. Deep breath, hold. Birthday candle. Close your eyes. Ready, inhale. Hold. Exhale. Keep your eyes closed just a few more seconds. Your eyes. All right, let's do this. Taking a look here, Algebra Review, we're continuing with radicals. Make sure you get a date, time, and location as well as a parental sign-off. What are we doing today? We are, like previous algebra lesson, we did computational math with fractions and solving for variables. Today, we're going to add, subtract, simplify, multiply, and divide radicals, better known as square roots. We're going to start by simplifying radicals. Now, there's a reason why we have a couple here, because this simplification method I label going on a date. So let me show you what I mean. I have a hokey storyline for a lot of stuff. You'll get used to it. So here we are. We're going to simplify radical 108 here. And we start by factoring. It doesn't matter how you factor. You're going to factor tree it. I tend to just use 2 all the way down, if it's even. Obviously 27, we can't use 2. And you factor so you get all the way down to the prime numbers. See the prime numbers here? These are what I will call the leaves. Versus the non-prime numbers are the branches. So you're only looking at the leaves when you simplify. And here's my storyline. If you have a date, which means a double, you get to go out. But when we refer to a couple, there goes a cute couple. Notice it's singular. There goes a cute couple. So when you bring that date out, a pair of 2s, it's going to be a singular 2. And then here I have a date of 3s. They're going to come out. A singular 3. Now Lonely here has no date, stays home, orders Uber Eats. This on the outside multiplies, not adds, 2 times 3. So the simplification of root 108 is going to be 6 root 3. That's the simplification of 108. Let's do the simplification. Now we have something already on the outside, and we are going to simplify what's on the inside. Once again, you're only looking at these prime numbers. We have a pair of 3s get to go out as a single couple, quote unquote. So on the outside, 5 root 54 simplified looks like this. 3 times 5. Then I have a 2 and a 3 without a date. They stay home, have a party, and that's going to be 6. I'd like you to just pause the video briefly and rehearse to yourself verbally. Just take literally 20 seconds. How do you simplify radicals? Tell yourself. Pause. Welcome back. Hopefully you actually paused there. So this page, you're going to do on your own. Ready? Pause the video. You are welcome back. Switching to a red pen. I'm going to do this kind of quickly because you should have the work already on your paper. So the 3's come out. So you should have 3 root 7, and that is as far as you can go there. This one. If you factored it differently, that's fine. Your prime numbers will still be the same. So we take a look here. Once again, you're focused only on the prime numbers. Who has a date? A pair of 2's, a single 2 comes out. Another pair of 2's, a single 2 comes out. And then a 3 times a 5, it's going to be 15. So 240 simplified is going to be 4 root 15. That's simplifying radicals. Adding radicals. I want you to note that this has been color-coded for you. I want you to physically collect these variables and add them up. Physically collect. Watch what I mean. Underline anything with a z. We're going to add, that's negative z plus 1z. So this ends up being negative 6z. Now I'm going to double underline the x's. This is called physically collecting. That's 3x minus 2x. So that's going to be positive 1x. I'm going to triple underline the y's. Underlining, or you can circle or make boxes, whatever. You do some sort of physical notation to connect the numbers. That's 8y minus 5y. That's going to be plus 3y. And that's as far as you can go there. This is super important. Radicals follow the same rules as variables. Radicals follow the same rules as variables. So if we're going to add this negative root 7 root 2 plus 3 root 5 plus 8 root 3 minus 2 root 5 minus 5 root 3 plus root 2. We do this. We collect like terms. Root 2. Technically, that's negative 7 root 2 plus 1 root 2. That's going to be negative 6 root 2. Notice, just like when we added with the variables, the variable itself did not change. That did not change. Let's do the root 5. So I have 3 root 5 minus 2 root 5. That's going to be plus 1 root 5. And then I have 8 root 3 and minus 5 root 3. That's going to be plus 3 root 3. Radicals follow the exact same rules as variables. Now, taking a look at this problem, it looks like nothing matches. So you're like, I can't collect like terms. There's nothing alike. However, notice some of these numbers, some of these radicals can be simplified. So you always want to simplify everything before you add or subtract. Okay, I broke down everything, even though not all of them simplify. Take a close look here. We have a pair of 2's. The 2's come out. There's a negative sign, so this is going to be -2 square root of 5. Why? Because 5 is what's left behind there. Coming over here, I have a pair of 3's. One pair of 3 comes out. 3 times 3 on the outside, that's going to be -9 root 2. There's no pairs here, so it stays -3 root 5. No one goes out because no one has a date. Here we have a pair of 3's. 3 comes out. 3 times 2, that's going to be +6 root 5. Now we collect like terms. Look very carefully. Root 5, root 5, root 5. Aha! There are like terms. Now we collect. -2 root 5 minus 3 root 5. That's -5 root 5 plus 6 is going to end up being 1 root 5 because that was -5 plus 6. Minus 9 root 2, and that is as far as you can go. This would be like saying 1x minus 9y. You can't do anything else with that. Radicals follow the same rules as variables. You try this one on your own. Pause the video. Welcome back. Let's see how you did. So this stays -2 root 5. This becomes, let me move this down here, -2. This one you can factor. That's 2 and 9. 3 and 3, so a 3 came out, so that's going to be -9 root 2. That's a 1 and a 2. It stays because there's no dates, so that's going to be +3 root 2. This last one, 2 and 10, 2 and 5. A pair of 2's come out. 2 times 2, that's going to be +4 root 5. We collect like terms, root 5 and root 5, that's -2 plus 4 is going to be +2 root 5. And then the 2, -9 root 2 plus 3 root 2 is going to be -6 root 2. Now, if you just switch the order, that's perfectly fine. If you have -6 root 2 plus 2 root 5, that's fine. That's adding and subtracting radicals. Now we're going to multiply radicals. Say this with me. Outies, outies, innies, simplify. Outies, innies, simplify. Outies, innies, simplify. There's a reason for the gestures, guys. Get used to it. Outies, innies, simplify. Outies, innies, simplify. Let me explain what this means. Outies, innies, simplify. When you're multiplying radicals, you want to multiply the outies. Obviously, this is a slang term. Outies means the outside coefficient. We call these coefficients if they're on the outside of the radical. So, outies. 3 times 7 is 21. Innies. 3 times 6. Now, there's a reason I'm not actually multiplying that into 18, because I'm going to simplify, and the key to multiplying is not multiplying, it's factoring. So I'm just going to factor both of these. I have a 1 and a 3. and a 2 and a 3. So I can see there's a date here, and the date is a pair of 3s, and they come out as 1. So 3 times 21 is going to end up being 63 square root, and I end up with 1 times 2, which is 2. Outies, innies, simplify. Outies, innies, simplify. You're going to pause the video and attempt to do this on your own in pencil, then grab a red pen and restart. Students, you got your red pen handy? Now you're correcting. You worked in pencil, you correct in red. Here we go. Outies. Innies. Simplify. Five times 14 is going to be 70. If you're like, how'd you do that? Well, 5 times 4 is 20. Carry the 2, 70. So it is 70 square root of 3. Outies, innies, simplify. If you got this correct, big star smiley. Woo woo, I'm so amazing. If you got it incorrect, I expect a little note. What are you going to remember next time? Dividing, same format. Outies, innies, simplify. Outies, innies, simplify. Outies, innies, simplify. Okay, so we're dividing with radicals. So step number 1 is you reduce the outies if at all possible. So we have 24 and 4. That is reducible. 4 goes in there 6 times. 4 goes in there once. Yay. Outies. Now we do the innies, if at all possible. 21 and 15, both are divisible by 3. So that's going to be a 7 and a 5. Now I'm going to write the clean up version, if you will. We have 6 root 5 over essentially root 7. Very important. When you simplify a radical, you cannot leave a radical in the denominator. Those evil radicals. You don't want a radical in your basement. Storyline, hokey storyline. You do not want a radical in your quote-unquote basement. The way you get rid of the radical is you multiply top and bottom by the exact same thing, just like you do the same thing when you do equations to keep it balanced. So right here, we're going to multiply top by root 7, bottom by root 7. We end up with is 6 root 35. Root 7 times root 7 technically is root 49. But root 49 is perfect. Root 49 simply becomes 7. Any radical times itself is just the number on the inside. So root 7 times root 7 is 7. Root 3 times root 3 is 3. Root 5 times root 5 is 5. Root 11 times root 11 is 11. Root 223 times root 223 is 223. Then you look, you can see if you can reduce the outies again. You can't. There's no innies to reduce. Therefore, we call it quits. This is the final version. Get your pencil. Do this on your own. Pause. Get your red pen. Get ready to correct. I need to see the work in pencil, the correction in red. Here we go. Outies, innies, simplify. Your outies should reduce a 7 on the outside and a 1. Innies, 32 and 12. Both are divisible by, let's see what number is the biggest. 4. Both are divisible by 4. So we're going to divide both sides by 4. And now we clean up a little, and this is basically going to be the square root of 8 over 7 square root of 3. Not done yet. That's outies, that's innies. Now we have to simplify top and bottom by root 3. Any radical times itself is just the number on the inside, so that's 3. Okay, watch very carefully. There's a little bit more simplification we have here. We have 8 times 3 at the top, and now we have 21 down below. You think you're done. Now, if you got that far, if this was a test, you would be getting partial credit, but there's one little caveat here. That 8 can be broken down. It can be factored to 2 times 2 times 2, and then we have the 3 here, which means we have a pair of 2's that can come out. Any date under the radical, all dates get to go out. If you got a date, you get to go out. So the final version, because that pair of 2's there under the radical sign, should be 2 Now you ask yourself, can these outies reduce? Nope. Can't reduce the innies anymore. This is the final version. Get out that red pen. You got it correct. Big star smiley. Didn't get it correct? Perfectly fine. What are you going to remember next time? Now I want to show you the most important trick of the trade when it comes to radicals. We're going to pick up the pace here just a little bit. Watch very carefully. This will be so very helpful. Root 2 times root 2 square root of 4, right? Because 2 times 2 is 4. But root 4 is perfect. It just becomes 2. Root 7 times root 7 is root 49, but root 49 is perfect. It just becomes 7. I want you to mentally start getting rid of this middle step in your head. And I want you to go straight to this. Root 2 times root 2 is 2. Root 7 times root 7 is 7. See that shortcut? Root 5 squared looks like this. Didn't I tell you any radical times itself is just the number on the inside? So root 5 squared is simply 5. Root 17 squared is root 17 times root 17, which is 17. See how easy this is getting? You can do this. Oh, golly gee willikers, I added complexity. Now I have 3 root 2 times root 2. Watch carefully. Any radical times itself is just the number on the inside. So that root 2 and root 2 simply becomes 2. And you do this. 3 times 2 is, ta-da, 6. Let's see if you caught this. I'm going to give you 10 seconds. 6 root 5 times what is 30? 10 seconds. It's root 5. 6 root 5 times root 5. Root 5 times root 5 is 5. 6 times 5 is 30. Good night. What's going on here? I'd like you to take 20 seconds and try this on your own. Really try. It's okay to get it wrong, but really try. 20 seconds. What's really important is you don't try to solve this all in one step. You know at least this. If there's no radical over here, somehow we just kissed it goodbye and made it go away. How did we do that? Well, we start by root 2 and we do times by another root 2, because root 2 times root 2 will give us 2. And now you ask yourself, what could I do to the 2 to get it down to a 1? I can divide by 2, because 2 divided by 2 is 1. But I want 7. What times 1 is 7? Therefore, your complete answer, what times root 2 is 7? The complete answer is, and this is a single entity, 7 root 2 over 2. You're brilliant. This page, my friends, you are doing on your own as fast as you can. Pause. Welcome back. I'm not going to explain these. I'm just going to give the answers. The complete answer for this is 4 root 3 over 3. Ta-da! Correct your work. When you get it correct, big star smiley. Woohoo! I'm amazing. That is so wonderful. Didn't get it right? Perfectly okay. Write down, what are you going to remember next time? Take about 1 minute, friends. Summarize, what are the 3 main things you remember from today's lesson? Do this on your own.